Hey, hi everyone. I hope everyone is doing well and really enjoying the content on product management brought to you by Product Managed. So, today's discussion is going to be on the technical side and it is going to focus on concepts of graph. Graphs are a type of data structures, right? So, remember, we have already covered list, advanced list and its operation. We have covered trees, we have covered heap, right? So yet another data structure type is called graph. So starting, I think, with the introduction on graphs. So what are graphs? Now, basically, graphs are your non-linear data structure that consists of nodes and edges, correct? And where obviously each edge, connects a pair of nodes, right? Nodes and graphs can represent entities such as people, cities, various other objects. And what are edges? Edges are nothing but they represent relationship, right, between the two nodes. So, example would be where if you want to model relationship between objects, right? You have social networks, you have computer network, you have traffic patterns, right, and genomic sequences. So all of this can be represented through various graph structures, right? So let's get into the basic terminology of graphs, right? So what are some of the terms that you should be aware of? So as mentioned, I think nodes, right? Nodes are points in graphs where basically your edges meet. What are edges? Edges are nothing but these are used to connect nodes and also represent a relationship between the nodes, correct? And then edges can be directed as well as undirected. So what it means is that you can represent a one-way relationship, which means you have a direction and representing a one-way relationship through the connection, right? Or if your edges are basically undirected, right? Which means the relationship can exist both the ways. So in this case, basically, you are doing a two-way relationship, right? So we'll look into what it means, but just wanted to highlight the directed and the undirected edge type. Then there is also the weights. So weights are basically, I would say, optional attributes that you can associate with the edge, right? So in certain relationship types between when you're defining nodes and connecting them with edges, you might want to give special preference, right, to certain edges. uh, Graph invariants are basically properties that are usually used when you are looking at transforming graphs. So in most cases, for example, if you are given a particular type of graph and you transfer it to some other type of graph, there would be some invariants that would be non-negotiables that will not change. So, for example, number of nodes, right? So, if you had, let's say, six nodes initially, you transform the graph. You would want to keep number of nodes also constant, right? Number of edges also, could be another one. The degree of each node, right? Degree means like let's say the connection, right, that each node has. So all of these essentially give you the invariants. Not all of these might be required in a particular graph when you're transforming it, but one or more probably can be required. So here, for example, we have a graph, right? As you can see, like I think you have multiple nodes, edges, and then you also have the weights, right, on each of the edges. So you have a 0 to 1 connected by an edge, and then it's given a weight of 6, correct? Similarly, you have 5 to 8, and then it's given a higher weightage of 12, correct? So this is how you represent a graph. Now, coming to the applications of graphs, right? So you have social networks, very well, let's say, known, I think, implementation of graphs. You can have relationships between people, right? Such as friends, or if you're looking at professional social connects, then it could be LinkedIn, right? Or if you're looking at followers, right, then it is Instagram. All of these social networking sites actually are underlying way the structure is actually using graphs. You can also model traffic patterns, right? So graphs are used to obviously use and look at traffic patterns and optimize the traffic flow. So some of the, I think, companies, let's say like Uber, Lyft, even to that matter, I think most of our, let's say, food tech companies, delivery companies will use in their underlying data graphs. They are not specifically looking to model traffic patterns, but they are looking to pattern and identify routes that are optimal from a delivery standpoint, for example, right? What is the shortest path, right, between point A and point B? That will be implemented using graph. Recommendation systems, I think we have seen that in all pretty much e-commerce categories, e-commerce sites, right? It's user preferences basically. Once you know, right, then you can recommend items, right? Genomic sequence, big one, I think, in the field of biological and medical sciences. Here, for example, you're modeling, I think, protein to protein sequences, and it's useful, I think, to understand certain type of, I think, implementations that lead to a particular sequence, right? Then you have fraud detection, which is definitely a very real world implication of a sort of a, let's say, identification of unusual activities. This is primarily going to be used by banks, and financial institutions where frauds do happen from time to time, right? And you are not only investigating it, but you are also trying to predict, correct, any type of fraud. Cyber security, again, basically, graphs will help you understand cyber threats, reveal network vulnerabilities, and detect, let's say, malware, intent. How do you do that? I can give you an example. Let's say you have a bunch of servers, right? You can assign them a starting IP address, and then all the IP addresses falling within, let's say, a particular range will fall under let's say, a network. Now, let's say you replicate that over a period of time, and then you have it in different, let's say, locations. A cybersecurity threat, if, let's say, for example, you had 10 of these groups, attack could be basically looking at a machine that is not part of these IPs that you have already configured within your network. Now, it is not as simple to identify an IP, because you can always mask IP, and you can always use proxies for attacks. But I'm just trying to help you understand that graphs, when they define networks within a graph, you will define the machines that are part of it and what relationship that they have. So, a particular machine could be like, let's say, hosting all the mobile apps. The other machine could be basically, let's say, your, a layer below the mobile app layer. So, like, I think, what is your origin and source. And similarly, if a machine is trying to access information that is not part of the network, you know that it is a threat, right? So, going on to the representation, right? The graph representation, I would suggest, if you have no understanding of metrics, skip this section. It requires basic understanding of matrices. What are matrices, rows, and columns? Uh, how do you represent a matrix item? If you want to understand more, I would say leave a comment. If you have an understanding, let's go ahead. So adjacency metrics, right? Basically, an adjacency matrix is a matrix where each entry at row and column represents an existence of an edge, right? So let's say, for example, you have nodes I and j, right? Matrix is a two-dimension, like, representation. So in that, every edge, which is a connection between nodes and ij, an entry in the ith row and jth column basically represents your edge. Adjacency lists, basically, you can also uh, look out and create a list of edges. So remember, I think we have talked about this list as a data structure where you can use each edge as a pair of nodes, and then there is this edge list, right? An edge list is a list of edge where each edge is represented as a pair of nodes and a weight, right? So remember, we talked about the weight, right? So edge list is nothing but where you're just representing the edge by a particular, let's say, number, and then you're also representing the weight along with the pair of nodes, right? So different ways of representing. By far, the most common usage is this adjacency matrix, where you are representing the relationship between two nodes through an entry in your matrix, right? Now, coming to the types of graphs, right? Different types of graphs that are there, and each one has its own pros and cons. We're not going to get into the details of advantage, disadvantage, but know it from an understanding perspective. So, directed and undirected graphs, again, we have looked at it where the graphs are pointing into a directed graph is essentially edges that are pointing in one direction. A one-way relationship exists. An undirected graph, that means connected in both the directions, right? And edges represent a two-way relationship, correct? So that is directed versus undirected. Weighted versus unweighted, pretty straightforward to understand. Weighted graphs where the edges are given weights, right? Or there is a cost associated. Or if you have unweighted, graph, there will be equal weightages, or there will be no weights at all. No weight is equal to obviously zero weight, right? And then you can also have cyclic and acyclic graphs. Cyclic graph has edges that form cycles. So basically, you might have four nodes. Completion of starting at one node and then completing it, right, could actually be used to call it a complete cycle, and that will mean it is a cyclic graph. A cyclic graph, no cycle. Now, this is an important category which is very useful from an interview perspective. Directed acyclic graphs, right? Directed means there is a one-way relationship, right? Acyclic means it's not completing the cycle, right? So, directed DAG in short forms is a directed graph that has no cycle and used to represent relationship between variables. Let's say in statistics or machine learning and other fields. I'll give you an example so that you understand what it means by a DAG, right? So DAGs are used to represent networks, let's say for example, social networks, transportation network, communication protocol networks, right? The nodes in the graphs are representing nodes in the network and edges represent connections, correct? Connections between them. Now, in terms of another area where DAGs are used, you can also model causal relationship between variables in statistics and machine learning or economics, right? Now, what do you mean by causal relationship? So basically, the causal relationship implies, my bad, this is not a causal, this is a causal relationship. So causal relationships basically mean, so causal relationship is basically defining uh, what has led to what, correct? What the cause and effect basically. So nodes basically represent variables and the edges represent the causal relationship, correct? So where is it used? I think in statistics, for example, temperatures, in different cities, or temperature and an outcome of a weather could be actually modeled using causal relationship. Then there is probabilistic graphic models. DAGs can also be used in that scenario. Uh, how do you do that? Nodes obviously in the graph represent variables, and edges represent conditional dependencies. Correct? Between the variables, correct? Another category is the time dependent graph. So time dependent graph has edges that changes over a time, which can be used to represent dynamic relationship. Probably an important category if your relationships are very dynamic and do not stay stagnant, right? Uh, you can, I think, definitely check out the different, I would say, categories or types of graphs. The most important ones I already highlighted. Leave a comment, I think, if you want me to cover, I think, anyone in specific details. Now, coming to graph algorithms, right? So in terms of graph algorithms, there are different types of algorithms that are used. Graph traversal algorithms, for example, uh, can be either your depth first or breadth first, all right? Then there are these longest path algorithms, or the algorithms. Basically, path algorithms are used to find either the longest or the shortest path between two nodes. You specify a starting point, you specify an endpoint, and then it tells you, the algorithm will tell you the longest or the shortest path. Minimum spanning tree graphs are algorithm. This is again related to the concept of weights, right? And minimum spanning tree graphs are algorithms that find the subset of edges, right? So out of the, let's say, 10 edges that you have, it will find you the subset of edges that connect all the nodes, right, in a graph while minimizing the total weight, correct? So similarly, you could have the shortest path algorithm. You could have an algorithm that says that reaching from node A to node B while minimizing the weights or maximizing the weight is also possible, right? So different kind of algorithms you should know. There are definitely interview questions that can be asked on graph algorithms. I am not denying that. Uh, have I encountered graph algorithms questions? Uh, Probably once. I remember, I think long back, which was related to identifying two, given I think a graph structure, identify or create I think a pseudo algorithm that gives you the shortest possible path between two nodes. And how would you do that, right? So I had to just talk about it and make them understand what is my thought process. So here, for example, I am looking at the longest path algorithm, right? Now, the longest path algorithm, if you look at this, right, I am specifying my starting point and my end point. So my starting point is 1 and my end point is 5, correct? This, and I have to find the longest path in this whole graph structure. So it could be obviously 1, 0, 2, 3, 6, 8, 5, right? All the combinations and then the calculations. So how does the algorithm do it, right? The algorithm will start with calculating all the possible routes and then calculating the sum of those. So here, for example, 1 to 4, if you look at it, it is 14. 4 to then going to 8, right? It is 6. Then 8 to 6 will be 16. So likewise, if you look at this and calculate the sum, it will be 84, and this is the longest path. If you try to take any other path, it will not be the longest path, right? So you can ask like, what is the benefit of finding the longest path? I think one advantage could be that, let's say you have warehouses that you want to establish, right? Warehouses are typically set at the outskirt of the city because your airplanes or railway cargo services are basically set outside the city. So you would want it to be farthest from the city, right? From the central point. Why would you want it to be the farthest? Because that way, when you are picking up the warehouse cargoes from the outside of the city, the delivery can be covering maximum number of areas, right? If it is the shortest path, then time becomes important, right? Shortest path, let's say for example, if you assign weights as your time, then you can also request the algorithm to give you the shortest path, which will lead to the least amount of time to deliver a particular, let's say, cargo item. The largest path or the longest path, as I mentioned, right, could be used to establish where should I, given my city structure, locate the warehouses, right? So I hope this video basically gave you good idea of graphs. I might do another video on the implementation part, which is using certain graph structures and understanding the implementation of those graph algorithms, graph structures in Python. But do leave a comment, I think, if you have specific requests, on these data structures related to graph. So until next time, hope you like the content. Don't hesitate to leave a comment and do like and subscribe to my channel.